Can we explain beam analysis in 5 minutes? Let's find out. Beams are one of the most commonly used elements in construction, and understanding how to analyze them is fundamental to civil engineers. For first-timers, seeing analysis like this is daunting. Even experienced civil engineers misunderstand these diagrams. But in the next 5 minutes, I want to give you a beginner's guide to how these diagrams work and how you can create your own. But first, let's take a look at the first principles. Beams come in a wide range of shapes, sizes, and materials. When we apply a force to the beam, we generate internal forces inside the beam. There are two types of internal forces which we generate. Normal forces act along the length of the beam and act in compression or in tension. You can see here when we apply a force to the beam, we generate tension in the top of the beam where we're pulling the beam to a greater length, and compression in the bottom of the beam when we're squeezing the beam inwards. Shear forces are slightly easier to understand and just act parallel to the direction of the load. We can simplify these two internal force components into what we call shear force and bending moment. We consider these two fundamentals in all beam analysis. Applied forces fall into three different categories. Point loads, which is a force applied to a single point found on the beam. A distributed load, where the force is spread over a length and acts more as a pressure. And a concentrated moment is where a pure moment acts on a beam at a given position. There are then three types of supports: pin supports, roller supports, and fixed supports. The differences between these are the restraints they provide to the beam. Pin supports restrain the beam in both horizontal and vertical directions, whereas roller supports only provide support in one direction. Fixed supports provide restraint in the vertical and horizontal directions and also provide rotational restraint. Let's look at the stages of analysing a beam. First, we need to draw the free body force diagram. Then we calculate the reactions, bending, shear force, and finally the deflection. We draw a free body force diagram showing the forces applied and identify the support locations and the support types. To calculate reactions, we need to use equilibrium equations, where the sum of the vertical and horizontal forces is 0, and the sum of the moments acting in the beam is 0. There are two types of cases when using equilibrium equations. Statically determinate is where you can create the same number of equations as unknowns, and therefore solve all of the equations. Statically indeterminate is slightly more difficult, and this is where you have more unknowns or variables than equations. In this case, you have to do more advanced methods, such as moment redistribution, to find the internal forces. After you've calculated the reactions, you can calculate the shear force. To calculate the shear force, you have to work from left to right across the beam and sum the reactions and applied forces at each point where they're applied. Bending moment is a little more complicated. Here again, you have to work from left to right and calculate the moments of everything left of each point you're interested in, and working your way across to the end of the beam. So after hearing that, you must be hoping that there's an easier way to form this kind of beam analysis, rather than using the different hand calculation methods, and you'd be right. So if you head over to Civils.ai, and then here you can actually perform this kind of beam analysis directly from your web browser. So after you've loaded the page, you'll see in the center of the screen, a beam has loaded here. And at the top here, you'll actually be able to control different properties of the beam, and it will update automatically. So you can change the beam length with these controls. You can change the properties of the beam itself using these different controls here. So you can change the second moment of area and the Young's modulus, or you can select a standard steel section size from here and update the beam with it. You can then add, or you can change or add point loads, pin supports in here. So if I want to add a new pin support, let's say in the center, I can just go ahead and add that and it will update automatically. I can even change this to a spring support, which is something we didn't cover in the video, but you can read up on that if you're interested. And you can add in or you can modify any of the point loads you've already added. So if I want to create a new point load, let's say 2.5 meters, I can go ahead and add that there. And then I can adjust or add different distributed loads. So I'll add one here that, is say like 30 kilonewtons, so it's actually varying. And then if I want to, I can actually change, so these are pinned connections here. I can actually go ahead and add a fixed connection at either end of the beam. And now let's look at what's going on down here. So if I'm looking at bending moment here, this diagram will be updating automatically, and you'll be able to see the maximum bending moment that's being predicted and the minimum bending moment that's being predicted. And you can see along the beam exactly what's being recorded at each point. You can also change and view shear force, and you can also see deflection. And if you are updating these different positions and moving things around, this will all update in real time. And then once you're happy with your calculation, you can either save it so you can come back and view it later, or you can go ahead and download this calculation as a PDF. Check out www.civils.ai for more information.